Hi everyone, I am 𝗶𝗵𝗀. I am based on ZEISS Innovation Center, California, in Bay Area, in Dublin, California. Thank you for joining us today to another episode of ZEISS Microminutes. Let me start with this. Okay. As I mentioned before, I am 𝗶𝗵𝗀. I am an applications engineer based in ZEISS Microscopy Customer Center in Dublin, California. And today I will discussing about automated image and large area imaging using SmartSEM Touch. This is a good opportunity for a good reminder. This is on a series of episodes from Microminutes. The upcoming episode is on October 17. If you are interested in cryo application, this will be really nice opportunity to scan the QR that you are seeing on the screen now, activate the notifications. Other interesting topic that is coming is an automatic imaging analysis using 𝗏𝗏 Pro, which is our artificial intelligence-based platform. If you are interested in this kind of topics, please scan the QR code, and you can see the notifications and be aware of our next Microminutes. Okay, let's start now. Please, if you have any questions, please input your question in the chat, and I will be glad to answer your question in the final part of these Microminutes. Okay, here again, our SmartSEM Touch platform is an expanding platform or a platform that allows to expand your electron imaging workflow to a real multi-user environment. We are going discussing probably some issues that could be sound familiar if you are using electron microscope for a while, and see how this platform can help you in your day-by-day operation of your microscope. Okay, let me do this first. Let me put here my laser, and let me do this again. Okay, let's discuss about SmartSEM Touch, and let me introduce you if you don't know about SmartSEM Touch and what is the capabilities of SmartSEM Touch and how SmartSEM Touch can help you in your day-by-day imaging workflow for electron microscope, scanning electron microscope, basically. Let's discuss some facts that probably is familiar for you. If you are using scanning electron microscope for a while, you can identify that same system are required for different users in a different expert level. Of course, these instruments is expected that are used for many people from different labs, from different, of course, level of expertise, which could be difficult and sometimes could be the user be overwhelmed, but for the information and how to use different detectors, different imaging conditions, and of course, probably the more experienced user is tied to the microscope because always has to be with this, user that don't have experience. And of course, it's hard to do another task if you are aware of only the microscope. Okay, let's move on. Automated imaging process could be hard and time-consuming. If you are trying before, probably you are familiar with the issue that you have to create a protocol, and you have to test it, go back again, probably adjust some parameters, and you have to, jump between testing, go back to the, the previous step and adjust again. And of course, this is time consuming. Will be a really nice feature if you can create a very, fast protocol and only running, because you don't want to spend a lot of time, again, and testing and adjusting your protocol. Other important fact is training user. Of course, time consuming. This is related with the first topic. If you are the person in charge of the microscope, of course, you have to train new users. And if you have rotation in the lab, with different users, of course, you have to spend time doing new training every single time with every single user. Another fact, time inspection routines via back to location feature could be challenging. If you, for example, forgot to save the position and you have a really good feature, a really good image, and you want to relocate that again, probably it's difficult, of course, because we are evaluating very, narrow field of view, and try to find this area again could be challenging. And of course, mislabeled samples is another fact, another challenging fact, because probably you are evaluating very similar samples and you don't want to, mislabel that specific sample, because probably that is a critical sample and you don't want to, screw your experiment or your imaging workflow. Then, SmartSEM Touch is a really good feature. It's a really good platform and have with very good benefit for it, even for academic customer and for industrial customer. For example, in academic customer environment, you have multi-users, teaching environment, and you want to easy of use and access this new user and reduce training costs. In industrial customer, for example, for visual inspection, you want automatic acquisitions and access the operation and increase the productivity. Of course, this last part, of course, can be applied to academic customer also. Let's see how SmartSEM Touch can help you with this kind of task. Now, Chris will help me with the introduction part of SmartSEM Touch. Please go ahead, Chris.
Hi, this is Chris, and today I want to show you a more productive way to use your electron microscopes. In quality assurance, research and development, or failure investigation, an electron microscope is a central piece of equipment to image the smallest details on your samples at high resolution and even get contrast between different chemical compositions. Your microscope may be run and administered by a core of skilled super users, but new users, guests, students, or staff from other departments may also want to use it. How can you ensure the system is used efficiently to its full capabilities in such a multi-user environment? How can you ensure a consistent sample-driven workflow? Your experienced users need to train up new users and make sure all users can operate the microscope on their own. Some users may be specialized doing the same task repeatedly. For them, it has to be easy to repeat the same workflow again and again. If your control software isn't powerful and easy to use, your experienced users lose time training new users, your workflows aren't properly controlled, your productivity goes down, costs go up. We'd like to show you a better way. SmartSEM Touch is your solution for intuitive electron microscope operation. Let's have a look. A new user can be trained in less than 20 minutes. SmartSEM Touch has a simple and clear touchscreen user interface, but all of the superb imaging capabilities expected from a ZEISS microscope. You don't have to sacrifice quality for ease of use. Choose from pre-configured sample types or set up your own for consistent routine imaging workflows. Collect data from large areas with the sweep of your fingers. Operators can view data from 2 detectors simultaneously, then browse and view all images in context. Your experienced user's time is freed up, your workflows are repeatable, your training costs go down, your productivity goes up. SmartSEM Touch is part of the ZEISS software suite, helping you to control, connect, and interlink all kinds of different microscopes. If you want to know more, have a look at my other videos.
Okay, thank you, Chris. I come back here. Let me disappear for a moment because it's important that you see this part that is behind me. Let me do this. Okay. Now, let's see a little bit more detail about all this short explanation that Chris gave us some minutes ago. And let's see how this SmartSEM Touch platform works for you and how easy it is to create different protocols for automatic imaging and large area imaging. This is how SmartSEM Touch looks like. It's a really simple platform and really clean to operate the microscope. Here you are seeing the software and the software how it looks like. This is the camera that points inside of the chamber. Here in the right down corner are you seeing the microscope. Right now we are going to introduce the sample inside the microscope. First we are venting the chamber. We only have to hit in the vent bottom. Wait until the chamber vent. Now we are approaching to the microscope, and after the sample is the chamber is vented, we can load the sample. We only open the chamber door. This is a draw type chamber door. Now we are going to introduce a sample holder with the sample inside. This is only important that you have to fit the dovetail in the sample holder with the stage, and once you face this, you can only sight your sample, and that's it. This is the sample that we are using today, two metallographic samples. We send out the napkin and we can take a picture of the sample, and that is very useful to navigate. We swing back our napkin and we are ready to pump our chamber. Very easy, only one hand, that's it. And now we are going to hit on pump to standby. First, let me get rid of this image here, and now we are pumping. Let me go back again, and I can explain in more detail this part. Right now, we are set up our sample, hit on the sample holder, and pick the sample holder that we are using now. With this cool feature, we can create an envelope, and as you can see, this blue envelope here shows the height guess and the sample diameter. You can adjust with these slide bars. Once you are happy with that, you can go back. This is important to avoid any collision inside of the chamber. We select the sample material that we are using. You can see here the list of the initial parameters for our imaging sessions. And after that, we go through these sample positions. We can operate the tilting and the rotation, adjust tilting and rotation for our sample, and adjust the height guess, the vertical position of our sample. After we adjust the vertical position for our sample holder, we can now hit in the napkin image there, and that will position the sample holder under the beam to start imaging. After we hit on the start imaging, automatically the system will drive us to this image tab where we can select all the parameters for imaging and start imaging. First, of course, we need to adjust brightness and contrast. We can use our automatically condition from brightness and contrast. This bringing us the proper adjustment for brightness and contrast. And after that, we can hit on focus, adjust automatically the out of focus conditions. And it's very simple. We only have to wait a couple of seconds until the auto running focus protocols ends. And now we are on focus. We can change the voltage, the acceleration voltage of our system, and adjust the aperture. This controls the beam current, and now adjust the quality of the image, the scan of the speed of our image. Of course, we can adjust the auto estimation. We have auto estimation, which is important for high quality image. Again, auto brightness and contrast. And after that, we are ready to save an image. As easy as that, it's very easy. You can use some image correction that we have here with SmartSEM Touch. We can even change between the detectors. And we have this cool feature. Let me go back here because I think it's important. You can have multiple detections with the same raster at the same time. Then, if we are happy with this, the detector that we previous pick, then we are going to automate now. Now, in the automation tab, we are going to select the area. You only have to drag your with your fingers the area that you want to. Now, we are going to confirm in which folder we want to save all the image, all the job that we are going to work. Now, we only input a name, create a folder name for this, select this folder, and now we are ready to imaging. We are going to select the out of focus condition that we want, and the overlap imaging, and only run the automation. After this, the system will drive the stage, and we move automatically the stage doing the automation imaging conditions. After that, we are going through the stitching part. This is important to create a real nice mosaic over our sample. Then we have to save first in the folder that we are working. Of course, saving, taking some time because remember, we are creating big tiles here. And after we perform the stitching process, we are ready to browse in our sample. And, now you can navigate if you are using like a Google Earth imaging, and you can pick the area of your interest. Right now we are seeing some grain boundaries of these metals, and we can, for example, study more about these boundaries or the void that we are seeing. Finally, we can mount these tiles over the napkin image, and we can see where this information came from our sample. And that's pretty much. I mean, of course, this took a while. I only speed the part of the acquisition image, but the rest of the the workflow is really seamless, and that's, of course, is very nice for day-by-day operation for big tiles. This is another example. For example, if you are using or you are working sample that looks very similar, this is a very good example. Here we have super wire with three different sections of this sample. Here we are adjusting the autofocus strategy that we want. We can use every image or every number of rows and the combination of that. And now we are only draw the area that we want to cover, and we can adjust the magnification and the field of view. As you can see, it's very fast, it's very easy. You don't have to waste time, and you can see on live if you change the magnification, how the field of view changes, and how many tiles will you get in your final result. And only drag that. And here, for example, we have 3 different areas, very, near areas, and you don't want to mislabel in these areas because, of course, you're having the information where this information came from, right? We go back again and select which is the proper scan speed that we want, and we create a real good image. This is the example of the image that we are collecting, and this is the estimate time that we are, from our workflow, for the entire workflow. After that, we only run an automation, and pretty much the same as the previous. After the run automation, this is the example of the image that we are having right now. Of course, the image is not still stitching. After the stitching process, in this example, I leave on purpose this part, show the grid and hide the grid. If you are hiding the grid, you are getting the full tiles. But this is a real cool feature to show, because if you enable the grid, you can have the previous image that compose the tiles. Here is a good example for that, because if we enable the grid, we can back and flip between the stitching and unstitched image. And this is important because probably you want to revisit some areas, but in the stitched image, of course, you are losing the metadata that provide me that information. And if you are interested, for example, in this area that I am pointing here, and you want to revisit this area, of course, you have to back to the unstitched image. Only I am showing right now this. If you click on the area, on the specific area that you want, this button enable again, and you only have to hit on this button and back to this location. Now the stage will be moving to that position, to this. Remember, we are moving to the center of that position. Now I am selecting the secondary electron image to see the topographical details here, and we are going back to that specific area, and we can investigate more details about this area and create a new job for that specific workflow, for that specific area that we want to investigate. Of course, we need to adjust a little bit focus. Remember, always you can do this with your fingers. Of course, I am using the cursor here because it's easier to show this kind of movement. After we are happy with the focus, we adjust the speed of the scanning to have a less noisy image. Now out of brightness and contrast again, and that's pretty much the workflow for automatic image acquisitions and multiple areas acquisition. That, of course, will be helpful for daily using. That's pretty much. Now you are ready to save your image. Thank you very much. Now, I am collecting only in 2 different detectors. Backscatter on the outer image, secondary electrons on the picture-in-picture image. You can flip between 2. Backscatter now in the bigger image. secondary electrons in the bigger image and backscatter in this image. And that's it. Okay, that's pretty much. I expect you enjoyed this one and see the potential if you don't have this feature or if you don't know how to use it. Yeah, this is very educative for that. Useful links and resources. Here you can see the upcoming ZMCC workshop. This workshop is intended for increase your skills using size microscope, light microscope, electron microscope. In the sites portal is another cool feature to see different kind of materials, training materials. Yeah, we upload periodically different kind of materials. And in the other corner, in the other QR, is the upcoming live streams. Please subscribe and activate the notification, and you will notified about the upcoming streaming. If you have any questions, now is the right time for the questions. Let me go back here and let me put back this one. Yeah. Again. Yeah, we don't have any question in the chat now. Okay, I expect you enjoyed this microminutes, and I hope to see you again in a couple of microminutes. Yeah, bye-bye.